Alright, you ever get mad at your math teachers for assigning a whole bunch of problems and you're like, come on, man, or woman, I get it. Like, I know how to do these. Why are you making me do like 20 of them? Well, just imagine what it's like for me doing these. I mean, I've been doing the chain rule for hundreds of years. Oh, you should feel bad for me. So the big mistake that people make when they're doing the chain rule is they just want to go busting in and take the derivative of the inside thing before there's the two steps, right? So the first thing is the derivative of the outside. This is the derivative of something to the 37th power. And the derivative of something to the 37 is 37 something to the 36. That's the power rule. And then we multiply by the derivative of what's inside. So you do not do both of those things at the same step. That is the thing that we're practicing. And you know, I mean, what do I have you doing here? Is it about 20 problems? Less than that. So, I mean, you got to get some practice. Practice. Talking about practice. You guys know who Allen Iverson is? He's a basketball player for I think he was in the 76ers when this particular incident came to pass. But there's a great thing where he missed a practice and there's a press conference, and the press was asking him about, you know, why did he miss practice? And he just went on this rant about, he was a really, really good player. He went on this rant about that it was just anyway, you should look it up. Look it up on YouTube. Allen Iverson, practice. If you look that up, you'll find it. It's pretty amazing. So we're talking about practice. So here, let's see. The derivative of something to the negative 2 is negative 2 times the something, which I'm just going to leave alone for right now, although I am going to write it like that because that's more calculus friendly, to the negative third. All right, that's my power rule, times the derivative of what's inside, which is 3x squared plus 7x to the negative 2. And, you know, like all these, you want to try to simplify that? Go ahead. But I don't know where you think you're going to get. This one I'm going to rewrite because if I can, I mean, it's not like I'm afraid of the quotient rule or anything, but the quotient rule is kind of messy. Of the different rules that we have, you could make a pretty good case that it's the messiest of them. So if I can rewrite something like this is not my derivative yet, right? This is just the original thing rewritten. If I could rewrite it and get out of having to do the quotient rule, then I think I'm going to take that option. So now I've got just a chain rule. So negative 12 times thing, I'm not going to mess with it yet. Don't do it. And then minus 4 times the derivative of what's inside. 6x minus 2. If you're a little bit lazy, sloppy, whatever about writing parentheses, if you wrote this answer and you left those parentheses off, that is wrong. And that's not me being fussy, that is me just respecting the agreement that all of us who have gotten into this math business together, we have a pact. We signed a deal, the PEMDAS thing. I know that sounds like, you're like, oh, seriously, PEMDAS? But the order of operations, it really matters because you get different things. So if you leave these parentheses out right here, that's wrong. Sorry. And I will mark it as such. This one needs a rewrite that I think I'm going to go ahead and do here instead of trying to juggle it in my head. Right? That's the more calculus-friendly way of writing that. Okay, so let's see if we can manage this. This looks like the little Russian doll thing here. I've got, just by looking at the parentheses, I can see that I have 2 layers here. So there's going to be 2 layers of chain rule that happen here. Our little Matryoshka doll. At the outermost layer, I just have something to the 1/2. So 1/2 times the something, which I'm not touching now. Not touching that, so that's still there, to the negative 1/2. And now I need to multiply by the derivative of what's inside. That's this. Okay, so I'm going to multiply by the derivative of what's inside. Derivative of 4 is 0, the derivative of this. Okay, so here I run into now another layer of chain rule. So the derivative of that is 1/2 times 3x to the negative 1/2 times the derivative of what's inside. I've had students, I don't know, maybe you fall into this camp, who had a hard time, especially when there's more than one layer, a hard time knowing when they're done, like when there are no more what's insides. And I found it's a little tricky to answer that question. I guess it's tricky to satisfy that student. The way I think about it is when I take the derivative of this 3x right here, the derivative of 3x really is 3. Like there's nothing else going on there. There's not like a 3 and the x isn't really an x, it's some other like 3 sine x or whatever. This is just 3x, right? The derivative of 3x really is 3. Whereas the derivative of 3x to the 1/2, 1/2 times 3x to the negative 1/2, it's not really just that because this wasn't just an x inside. So another way of understanding it is if you look at that, how many layers of parentheses, you should be convinced that that's how many layers of chain rule. You're going to have 2 sets of parentheses like this, nested parentheses, then you're going to have 1, 2 things that pop out because of the chain rule, 2 derivatives of what's inside. I don't know if that helps. Maybe. All right. 15. I'm going to think about that little 1 over x squared is x to the negative 2. So the derivative of sine whatever is cosine whatever times the derivative of what's inside. Or 17. So here, for calculus purposes, I think we've already talked about the unfortunateness of the this notation for us. So that cosine to the 5th, that I really think is worth rewriting because you can see much better now what's going on. So the derivative of that is derivative of 4 times sin to the 5th is 20 times that same something to the 4th times the derivative of what's inside. 19 cosine. So this looks like it's going to have a couple layers here. It needs a rewrite. Now I've got the cosine of 3x to the 1/2 squared. So hopefully we can successfully rewrite it like that. If you can't successfully rewrite it, then that presents a pretty insurmountable obstacle to getting to the right answer. So I got something squared, so 2 times that thing, not messing with the thing yet. And also this, just point out the 2 levels here, the 2 layers, so I'm expecting that. Extra Russian doll surprise. So now the derivative of what's inside, derivative of cosine of whatever, is negative sine of whatever times the derivative of what's inside. And now the derivative of 3x to the 1/2 really is 3/2 x to the negative 1/2. Right? And also, since I had 2 layers, I was expecting 1, 2 things to pop out. So that is the end. Number 21. Let's see. I'm going to do a quick, I'm going to rewrite it. I don't want to inspire bad habits. I've been doing this for hundreds of years, as I think I mentioned already. You are just getting started with your life experience of the chain rule. So probably you want to be doing that and not trying to juggle this without the rewrite. All right, so 2 times sin squared, that's going to be 4 something to the first power times the derivative of what's inside. The derivative of secant of whatever is secant whatever tangent whatever, and then the derivative of that is 7x to the sixth. The rewrite really makes it much easier. So that's a thing that we like to rewrite, that secant squared, and also, of course, our square roots. So cosine of 5x all to the 1/2. So the derivative of that is 1/2 times the cosine of 5x to the negative 1/2 times the derivative of what's inside. Derivative of cosine of whatever is negative sine of whatever, and then the derivative of inside of that is 5. Right? And we were expecting 2 layers. Like a little Russian doll. Let's see. Does this need a rewrite? I don't think this one does. So let's see if we can just throw it down. So the derivative of something to the negative third is negative 3 times that whole thing, x plus cosecant of x cubed plus 3, all to the negative 4. And then the derivative of what's inside that, if I'm looking at, I'm expecting 2 layers, right? Just like the past couple problems. Derivative of what's inside that is 1, that's the derivative of my x there, plus the derivative of cosecant of whatever is negative cosecant whatever cotangent whatever times the derivative of what's inside, which is 3x squared. So there might be like potential confusion in this one around where exactly does this go. Like, does that belong here? Yes. Or does it belong on the outside of this? No. It's the, when we're multiplying by the derivative of what's inside, it's the what's inside of the cosecant function. It's not the what's inside of this. So it doesn't have any business being out here where it would multiply back to that 1, because that was just an x here. The derivative of that x is 1, period. Period. Right? A few little adjustments to my math area here. 27. We have to go to 39. My goodness. All right. Find dy dx. So they're changing the notation on us, but we know it's the same thing. Okay, it looks like they're doing some, we got some combo stuff going on here with maybe some quotient rule and stuff. So let's see. I think I better rewrite it. I'm going to write it down. I just have to set a good example for you guys. Sine of 5x squared. Okay, so there's a product rule going on here, right? And at the highest level of doing this derivative, it's the product rule. It's going to organize what's going on. So dy dx is equal to the derivative of the first times the second plus the first times the derivative of the second. And when I do the derivative of the second, it's like a 2-layer chain rule. So the derivative of the second is 2 times the sine of 5x to the first power times the derivative of what's inside, cosine 5x, times the derivative of what's inside. A wee bit of simplifying you could do there if you want. 29. I think I can do this one without the rewrite. The only rewrite here would be the 1 over x is x to the negative 1, right? So let's see. Product rule. The derivative of the first times the second plus the first times the derivative of the second. The derivative of secant of whatever is secant whatever tangent whatever times the derivative of what's inside. All right. We're getting there. I'm only 15.5 minutes, so we're all right. All right, and 31. Cosine of cosine x. Now, who would do that? Who would take the cosine of a cosine? Well, I guess that happens. So dy dx is equal to, so the derivative of the cosine of whatever is negative sine of whatever, and then the derivative of what's inside that is negative sine of x. So you got to be careful here. If you're all excited about simplifying things, of course the two negative signs can cancel out, but this is the sine of cosine x and this is the sine of x. There is not any way that those can be combined or quote unquote simplified. It's just not possible because they're the sines of two different things. So that's it for that one. This one I think I better do the rewrite. And I don't know about you, but I am noticing 3 layers of parentheses here. So I think our Matryoshka got one level deeper here. Let's see if we can do it. Derivative of 3 times this, or sorry, of this to the third power rather, is 3 times that squared times the derivative of what's inside. The derivative of this thing is the derivative of cosine of whatever is negative sine of whatever. Okay, so we got one layer. I think I need another. Yeah, we're one layer in. And then now the derivative of cosine of whatever. So now I'm into this layer here. So the derivative of that is the cosine, derivative of sine of whatever is cosine of whatever, and then the derivative of the inside of that is 2. So there's our outermost, and then we had 1 chain rule, 2, 3, which is what we expected. Let's see. Do we need a rewrite on this one? I think we can maybe do it. Let's try this one without. So dy dx is equal to the derivative of the first is 7 times 5x plus 8 to the 6 times 5. Right? That's the derivative of the first, which did involve just a wee bit of chain rule. It's the derivative of the first times the second plus the first times the derivative of the second. And then the derivative of what's inside that is negative 1/2 x to the negative 1/2. Yeah, that wasn't so bad. 37, it looks like on the outside we've got, so on the outside I have the, like if you zoom out on this, it's the something to the third is the most outside layer what's going on. So the derivative of something to the third is 3 times that something to the second times the derivative of what's inside, and the derivative of what's inside this is going to be a chain rule problem. Quotient rule problem. So that's derivative of what's inside is low d high is just 1 minus high d low over low low. Definitely some simplifying that could happen there if you want to, but not going to do it. Let's see. Last one. So this is kind of sort of similar to the last one, except that in this one, the quotient rule, since the two things are raised to different powers, it's the quotient rule that's sort of dictating the order we do things in, or the first level. So quotient rule on this number 39, we have low, d high, right? And notice that that d high had a little chain rule, pop out that 2, minus high. Hi. How are you today? There's high d low, and there's the chain rule. It's going to pop that 8x out of there. So it's low d high, which included a chain rule, minus high d low also had its own little chain rule, over low low. How low can you go? And that, my friends, is it.